So next, I want to discuss the information. Okay, it's the underlying most difficult thing to grasp for a new user. Okay, the grid is pretty simple. It makes a grid of rectangular cells, right? So that those cells are typically packaged into smaller information, right? So let's take a look at with panels. Okay, so we'll drop a few panels in and we'll look at the information that we're being given. If you plug cells in to the panel, I want you to take a look at what it looks like. Okay, the cells right here are reading in packs of 4. Okay, they are all a width of 3 and a height of 8. Why do you think the rectangles are reading in packs of 4?
Because the 4 edges.
Good guess, but no. Not in this case. It's because the cells are being organized in rows. Okay? I'm going to jump into something real fast, and I don't want you to focus on what I'm doing right now. So if you can even look away, then look away. But I'm just going to drop a few things so you can see something. Okay, so I've got this. This basically just got me the centroid of all my surfaces. And then I can display a numerical value for each of those centroids. Okay, there we go. All right, I don't want you to focus on that right now. So what's happening is this counter is going to essentially count it's going to index out the families, I guess, or the packages of information. I call them sets. What we need to do now is plug in the original surfaces. So the cells are being read in groups of 4. They're being read in groups of 4 because each row is a set. And it goes from 0 to 1 to 2 to 3. And I mentioned when we were doing the ladybug stuff that your lists are going to start from 0. Now it becomes really important. We didn't really go into it back then, but now it's really important because your list starts from 0 because of computer programming language and syntax. You don't need to know much more than that. Just remember, it's very, very important. Lists start from 0. And that index is where that item lives in the list. Okay? That's how it's ordered. So if I was to change the size x, the extent y to a different value, then I get more counts. Also, the information being passed through changes. So if I want more in my row, I have more in my set. Now, if I was to expand this, what you'll find is that I have 8 sets of data that gets passed through. You'll see it here. Right? You have 1, 2, 3, 4, 5, 6, 7, 8. 8 sets with 5 in them. So ultimately, you have 40 cells. What I can do if I want to read all of those cells as one family, it's called flatten. Flattening takes these rows, takes that information in vertical rows, and just sprawls them out horizontally. So that it just goes 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 40. And flattening is done by right-clicking on the output. You can do it on input sides too. We'll talk about that in the future. But you right-click on the output and you do this. It's called flatten. And now that list is being read numerically all the way up to 40 different indices. The reason it reads 39 is because our index, our count, started at 0. Does that make some sense? You have no idea how you're going to use it yet, but it makes sense that you have those two options, right? All right. So now our list reads as a singular list of index items all the way down to 39. That should be clear, I think. So also, notice something else that changed. If I go back to before it's flattened, the wire is showing as a dashed line. That means that information is coming out in little packets known as sets. When it's flattened, it's a solid line. That means that only one set of information is being passed through. Clear? Okay. So, oh, I kind of want that. The information that's going to get passed through, now notice that while I've flattened the surfaces, right, or the cells rather, I flattened the cells. Coincidentally, the surfaces that are associated with the cells are also flattened. They get passed through into deconstruct brep. That information is flattened. You have 40 values coming from one source. However, you then look at the E for edges, and now you see that it's got the dashed line. Why is that? That's right, I didn't flatten it. But why would the edges deconstructed from surfaces not be flattened? Hmm? Similar, yeah. So that process happens over again. So this panel now on edges, now they're groups of 4, but it's a different kind of information. It's line-like curves. It's the edges. The edges are now packaged into groups of 4 for every single surface. The reason that that's important is because if I have two different geometries, let's say I'm just going to copy this. You guys don't have to follow along with this. I just want you to understand it. So don't do this with me right now. I'm just going to drop in a, let's do it this way. Point for that and params 0 less than 10. Plug that into Z. Get you up high like that. Okay. So what I've done here is created 2 of them. If I want to connect this information, if I want to select maybe just one of these cells and create a shaft, I need to be able to isolate them as a group. So for instance, I can let me turn the numbers off because they're going to get confusing. Do it that way. Okay. So for instance, I can grab an item from this list. An item meaning one set. And associate it with the similar item in the other set, and then create a loft between them. Okay, so that looks like this, and I'm going to explain this in greater detail later. I just want you to see it now. Under set and list, I can grab a list item. In this case, I'm going to grab this edge from that group list of edges. I'm going to grab item number anywhere from 0 to 39. I'm also going to do the same for this one. Same number. And then I'm going to loft them together. So I put in this set of curves, this set of curves, and that's what I get. Okay, so now you can see we're starting to move toward the type of information you're going to need for something like louvers. Right? See what I'm getting at here? And I can change it. So if I need, and right now this is in the wrong plane, but I'm just trying to get you to see the condition. If I need something that's horizontal based, I have that. Vertical, I have this. So actually I made it too far actually. I was thinking of a different orientation, but basically this slider only needs to go from 0 to 5. There we go. 0 is that. 1 would be that. 2 is that. 3 is that. And then 4 and 5. Oh, it's only the vertical ones, huh? Oh yeah, because there's only 4. So it only needs to go from 0 to 3. Sorry. But anyway, really all I did was connect the right kind of information. Okay? So I don't expect you to have a full working knowledge of that right now. I just wanted you to, A, understand and be able to construct, deconstruct, and reconstruct something. Okay? So I think you've got it now on that. The other thing is that I wanted you to understand that there are different formats of data that we have to pass through and, more importantly, connect. Okay? So we're gonna go through a series of exercises really understanding isolating information and modifying information, and then creating a degree of differential between packets of information as well, starting on Thursday. What questions do you have? Cool stuff, right? I mean, you're basically already creating facades and stuff. All right.